In Lesson 99, we'll be talking about uniform motion problems dealing with unequal distances. Now, we've done uniform motion problems dealing with equal distances, and we're always talking about a pair of distances in these problems. And we use those diagrams to help us. Like in equal distance, well, it's kind of self-explanatory. Both distances were the same. Now, in the next type that we've been doing, we add those two distances together. And we might have a problem like this, where they start from the same or from different spots and meet together. And there's some total distance there that we consider that n. And so that's another type that we've done where we add the two distances together to get a total. Now, this one is on unequal distances. And the one I just described, those distances, they may not be equal, but it's just a little bit different look to it. For example, we may have something like this, where we have d1, and then they give you the rest of this distance. They call that n, and then here's d2. So the way you would write that is d1 plus n equals d2. So like I said, that middle diagram there, those distances, they may or may not be equal to each other, but this new way is just a little bit different way of looking at unequal distances. Let's go ahead and do a practice problem. Let's read it through once. It's always what you should do on a practice problem or a word problem, is read it through one time first. The turtle had a 54-meter head start on the rabbit. How long will it take the rabbit to catch the turtle if the rabbit travels at 20 meters per second and the turtle travels at 2 meters per second? Okay, so let's just think about information that they've given us here. We know that the turtle had a 54-meter head start on the rabbit. So if we think about like a race, there would be a starting line, and the turtle is going to start up here, 54 meters ahead of the rabbit. Now, the turtle's going to start moving, and then the rabbit's eventually going to catch up with the turtle. So they'll end up at the same spot. And so this distance here, we'll call that d subscript t for turtle, and this is the distance that the rabbit traveled. Now, think about what's happening here. Think about that it had a head start, so it's like a race. They took off at the same time, and they catch each other. They have both traveled for the same amount of time. It's just that the rabbit's traveling faster. He's traveling 20 meters per second, so he covers a longer distance than the turtle, but they both traveled for the same time. So we could say that, let's just go ahead and write an equation out with the distances. We'd have 54 plus the turtle's distance, which we could write as a rate times time, rt t sub t is equal to r t sub r. Now, since the times are equal, we can just say that t sub t is equal to t sub r. And then we know that the rabbit's rate, r sub r, is equal to 20, and the turtle's rate, r sub t, is equal to 2 meters per second. That's what that m/s stands for, is meters per second. So now let's go ahead and substitute into our main equation there. 54 plus rt, that would equal 2. So we could just say 54 plus 2 times t sub t. Now the times are equal, so we really don't even need to worry about the subscripts. We can just say 2t is equal to the rabbit's rate of 20 times t. And we can solve for the time now. That's our question also. How long will it take the rabbit to catch the turtle? So if we subtract 2t from both sides, we'd have 54 is equal to 18t, and then divide both sides by 3, and we would get t is equal to 3 seconds. The time is in seconds on this one because the rate was meters per second. On a problem like this, one of the things that people get confused on is realizing that there are equal times here. But that's because they started at the same time, and then the rabbit catches the turtle. So that means they have both been traveling for the same amount of time. Their distances are different, though, because their speeds are different. If their times are the same, but their speeds are different, then their distances will also be different, because distance equals rate times time. And we could figure out how far each one of them traveled. The rabbit traveled 20 times 3 is 60 meters, and the turtle traveled 2 times 3 is 6 meters. And that makes sense that since the rabbit is traveling 10 times faster than the turtle, that it would have covered 10 times greater distance during the same amount of time. Let's do one more. Let's read it through first one time. At 5 a.m., the geese took flight and headed south at 20 miles per hour. At 8 a.m., the ducks took flight from the same location and also headed south. By 4 p.m., the geese were still 4 miles ahead of the ducks. How fast were the ducks traveling? Okay, so these word problems, there's a lot of information, so the best thing to do is just to start writing down what you know about and what has been given. And at 5 a.m., the geese took flight and headed south at 20 miles per hour. So we know that their rate, we could just say R subscript G for geese, is 20. The rate of the geese is 20 miles per hour. And then at 8 a.m., the ducks took flight from the same location and also headed south. So we can start a diagram. We know that the geese are traveling a certain distance. The ducks are also traveling a certain distance. And then by 4 p.m., the geese were still 4 miles ahead of the ducks. So at this particular time, at 4 p.m., the geese were still 4 miles ahead. So the distance that the geese had traveled was 4 miles more. So we could just put a 4 right here. And here's the distance the ducks had traveled. 4 miles less than the geese. And so there's an equation. The distance of the geese, or RGTG, is equal to the distance the ducks have traveled, RDTD, plus 4. So we have two equations there. We know how far the geese have traveled. We have an equation with all of our unknowns in it. A distance equation, in other words. And let's go ahead and see what else we can figure out. We need two more equations, and we know what time we started with the geese. They took off at 5, and our ending time, or the time that we want to make our description here, or figure out our speed, is at 4 p.m. There's always a place to start and a place to stop these word problems, and everything is basically ending around 4 p.m. And so we go from 5 a.m. to 4 p.m. That's a travel time of 11 hours. The geese had been flying for 11 hours at that time. And so we would just say the time for the geese equals 11. And then the ducks, they left at 8, and we're comparing everything to 4 p.m. So from 8 to 4, they had been traveling for 8 hours at that time. So at that time, after 8 hours of travel by the ducks, they still had 4 miles to go to catch up with the geese. So we have 4 equations now and 4 unknowns. We can figure out how fast the ducks were traveling. Let's just start substituting into our main distance equation. And so we have a rate for the geese of 20, a time of 11, and then a rate for the ducks. We don't know that. That's what we're trying to figure out. Their time was 8 hours, though, and then plus 4. So then we can multiply on the left. 20 times 11 is 220, is equal to 8 RD plus 4. Subtract 4 from both sides, and we get 216 is equal to 8 R subscript D. Divide both sides by 8, and we get a rate for the ducks of 27 miles per hour. So they were actually traveling faster than the geese. They just started a lot later. So on these uniform motion problems, that means like a constant speed. They're not like accelerating and decelerating and everything else. We can assume that the geese were traveling pretty much constantly at 20 miles per hour. The ducks were traveling constantly at 27 miles per hour. We set up our distance equation, and we find that since they took off from the same location, we start them at the same spot, and then at 4 p.m. we stop everything at 4 p.m. and we just design our little drawing so that the ducks are 4 miles behind the geese. Make sure you answer the question just what for they're asking for. We could figure out how far the geese had traveled. We just multiply that rate of 20 miles per hour by the time that they've been traveling. We could figure out how long or how far the ducks had traveled too. But they didn't ask us that. So make sure you answer the question just for what they're asking. Okay, well that's all for lesson 99.